Or at least enough to move to the next one. And try different exponents. 20, 2, 1, 0. I should be able to try these live. If I don't do x to the 5, and I do x to the 7. Wait, did it change anything? It is. The curve is getting more steep. Great. So this should be a straight line at the top. Okay, cool. Understanding this relationship between the value and exponent would be very helpful. Okay, I know math, thankfully, has a native function that makes sense. Replace the power function. So I'm going to keep this at 5. Well, x wasn't very enlightening. Oh wait, did I crash something? I did crash something. I guess you can't just use x like that. Which kind of makes sense, since x was e raised to a power. Okay, don't know why that's all white. Isn't this just a... because this is a constant, right? So I made this like 1, then it should be too high. I have to do something like maybe a half? Nah, I don't know. Oh, and I crashed it again. Okay. Log and square root. Some of these functions are more interesting when you play with them using pi. You can see that on line 8. Just find a macro that replaces any sub pi with that value. So I'll try log. Maybe this one will appear. You can see it barely in the corner there. If I did square root. Okay, this one appears, thankfully. Which I guess makes sense since this is pow with a half. Okay. Anyway, I think that's enough of that one. GLSL also has some unique native interpolation functions that are hardware accelerated. Like the step function that receives 2 parameters, the limited threshold, where the second one's the value you want to check or pass. The value under the limit will return 0, while anything above the limit will return 1. Okay, I'm gonna hopefully be able to copy this straight into Manim. Just delete all of this. See what this does. Great. So this is using the same logic as before to make sure the point is only within 0.02 of the actual value. So this makes sense. And so if I increase this from like to like 0.8 or something, I should move to the side. Okay, that makes perfect sense. However, I wonder why it's doing linear interpolation like this. Like there has to be an OpenGL function for linear interpolation. Like lerp or something. Mix. Type X and Y by A something. Mix. Type X and Y by A. So maybe what I can do, let me change this to a 5. Bring it to the middle. And then I'll try doing mix. Mix of color and green by percent. Great, and it worked because it live updated. So if I were to do percent plus like 0.2 or something. Wait, that, oh, now it's interpolating further to the green color, so this makes sense. Cool. Okay. Shaders aren't so bad. Okay, cool. Another unique function is smooth step. Given a range of 2 numbers and a value, this function will interpolate the value between the predefined range. The first 2 parameters are the beginning and end of the transition, while the third is the value to interpolate. How is this different from mix? 2 numbers and a value will interpolate the value between the defined range. 0 to 0.9 by the X value. Wait, first of all, I'm going to make sure this shader works. Remove all of that. Cool. If I run this. Great, so I get the same thing. Now let's see. Smooth step from 0.1 to 9. I guess the things less than 0.1 and greater than 0.9 are just being clamped to 1. And it's doing it by the X value. So this is a pretty straightforward one, I think. Using smooth step to draw the green line on the plot function for each position along the x-axis, this function makes a bump at a particular value of y. Oh, by connecting the 2 smooth steps. Dope. Place for line 20 and think of it as vertical cut. The background does look like a line, right? Wait, take a look at the falling function. Replace it for line 20. So I'm going to try doing that. But not in their engine. I have a better engine, so you know. I'm gonna try it here. And that crashed. Oh wait, that makes sense because I declared this twice. This makes less sense to me. Smooth step from 0.2 to 0.5 by... Oh, this does make sense, because this is clamping it from 0.2 to 0.5. Then I'm adding the negative curve from 0.5 to 0.8, so this does make sense. And I can make it wider by decreasing this, increasing that. Yeah, this makes sense. Cool. Sine and cosine. I know how sine and cosine works. Circle to describe all the relations between trigonometric functions and circles. The above animation does a beautiful job of visually summarizing these relationships. That's a nice animation. We should copy that for Twitter or something. Can I just live update this? Update that for Twitter or something. Can I just live update this? I can. Can you do Cozy again? No. Okay. Try the following exercise. Well, okay, so it'd be really nice if I could pass a time parameter to this, to the shader I'm using in Manim. Firstly, let me try just doing the sine of st.x. Okay, that didn't work. And I guess that makes sense because this is going from... What's the period of sine? It must be like 2 pi or something. Yeah, it is 2 pi. So I have to make this more frequent over. Won't I have to do this times 2 times pi? Oh, but it's going -2. And when it goes negative, it just goes off the screen. Whatever, I don't care. What I'm going to try to do is pass a time uniform to this. Just got back. If you haven't seen Shader Toy, it's worth a look for fun. Yeah, I've messed with Shader Toy a little. We actually managed to get a Shader Toy shader running in Manim. It wasn't too bad, but it wasn't as easy as copy and pasting either. Hopefully I can get it around as easy as copy and pasting. So I'm going to multiply the time here and just set the time to 0. And that wasn't very interesting. But what I'm going to try to do, I think I can do surface.addUpdater. I'll just call this update surface. And what I want to do here is say surface.shader.setUniform u_time. Then I have to get the time. Which you might think in Manim we just have scene.time or something. But you would be wrong. Okay, maybe I just need shader time. I can just have this be 0. And then add to it. Oh wait, I crashed something. I can tell because the window just disappeared. So I think this is non-local. Well, it's not changing anything. Which is unfortunate. Maybe if I... I don't know if this crashed or not. Dang. Oh, it's not playing. Hold on. If I don't embed and instead... Or was it playing? Okay, now it's updating. So how come when I did embed 2, it wasn't doing the updaters? There might be something wrong with embed 2. But I'm going to look at that. Well, the thing is, I've heard horror stories about people opening random links on Twitch and then like fucking. Okay, this is fine. I've actually seen this shader before. Okay, this is fine. I've actually seen this shader before. Wow, he goes into a lot of depth. I feel like the nose would be super hard. It's a hog to run at high res, the shader, but also amazing. Dude, this and the clothes. This guy has to be like a professional. Did he link the shader? I guess not. I think this is consistently at the top of shader toy. Yeah, this one. Luckily, I'm streaming from a different computer that I'm using here, so this isn't destroying my stream when I open this. But that's insanely cool. Okay. Okay, so there's a problem with embed 2 because it wasn't updating the time, or it wasn't calling the updater. So what I need it to do is call the updater. Wait, so maybe and I already PR'd it, so anything I change here won't necessarily be PR'd. But when it goes to interact, it's mostly just doing self.update. Oh, here. I think all I need here is self.update meshes. But that wouldn't make sense to add on the PR. Hold on. Because in the PR version of Manim, the mesh object doesn't exist yet. There we go. That's kind of trippy. It was a lot faster too. Okay, cool. Add U time to the X before computing the sign. Internalize that motion. Multiply X by pi. I did that. Multiply the time. Add 1 to the sign. I wonder if I can make the sign... I should be good enough at math to make the sign fit in the screen. But don't quote me on that. Firstly, I'm going to multiply by half. Okay. Then, I'm going to add a half. And that's it. Now I did it. I'm so good at this. If I were to... So I guess what it was talking about... Did that just crash? Oh, I know it crashed. Because I didn't use the time variable. But maybe if I did this plus shaders are really finicky about if you try to set a variable that isn't there, then it'll crash, which is kind of reasonable. But also, if you set a variable and don't use it, it'll also crash. Anyway, that's nice. I was able to get that working. Great. Compute the absolute value of the sign. It looks like the trace of a bouncing ball. Great. Compute the absolute value of the sign. It looks like the trace of a bouncing ball. So there's a sign. You can just say y equals abs of y. Oh, well, I changed it so it's always positive. So I'd want to not do that. Probably not do this. That's just going way too fast. Hold on. Let's divide that by 3 or something. Yeah, that kind of looks like a bouncing ball. I've been looking at GPU Rust. Write shaders safely in Rust. I haven't had time to dive in, but I think it's some really creative macros and tool chains. Nice. Hopefully, this is a lot of progress toward making shaders a little bit easier to understand in general. Hopefully I can get it to where anyone who has Manim installed can just like start playing with shaders if they want. I'm trying to make the hills stay in the same place. Cool. Anyway. Multiply my 2 did that. The absolute value did that. Extract just the fraction part of the resultant assign. What? Add the higher integer and the smaller integer of the resultant assign to the digital wave of 1 and -1 values. Didn't understand what that means. I'm running out of playlist. Is that referring to clamping? Yeah, I think so. Add the higher integer and the smaller integer of the resultant of sine x. What is a resultant? Is this the remainder? Sorry, just the fraction part. Should I know what resultant means? So maybe this just means whatever's returned from the expression. Okay, I'm gonna actually try doing this. So here's the sign. Nope, broke something. Probably because I didn't use the time. Oh my gosh, not like that. Hold on. Technical difficulties. There. Now the fract. It shouldn't be any harder than doing this, right? Okay, I don't understand that. Wait a second. So it looks like this. So this is oscillating between +1 and -1. And then I'm taking only the, oh wait. Then I'm taking only the decimal. So I guess it's always positive. When it becomes negative, it's jumping. It's doing this jump discontinuity to 1. Yeah, I don't know what this is doing. Maybe I should, but... The fractional part of x. X minus the floor of x. I guess for negative numbers, it just becomes positive. Oh, this function is non-negative. So at negative numbers, it does become positive. Interesting. Add the higher integer and smaller integer. Okay, so this should mean I take seal and then add. Yes. Should mean I take seal and then add. Yes. I did it. The square wave. Okay. It doesn't all fit, so I guess I'd want to do... This would have the amplitude. Let's make a that. I'm not sure what that is. I'm really drawing on a GPU. Okay, at the end of the last exercise, we introduced some new functions. It's time to experiment each one by uncounting the lines below one at a time. Get to know these functions and study how they behave. And now you're wondering why. A quick Google search on generative art will tell you. Keep in mind that these functions are as fence. We are mastering the movement in one dimension, up and down. Soon it'll be time for 2, 3, and 4 dimensions. Hardware communications. Is that a 12 or an L2? I2. Okay. Hardware cards, I2C and SPI are common for microcontrollers' digital signals. Gotcha. Okay, cool. Cool. We'll get there one day. Okay, and this is just going to show me how all these functions work. That's a pretty neat shader. Or like live rendering thing. It's really fast. Great documentation on more... This person has great documentation on more complex shaping functions that are extraordinarily helpful. Putting them in GLSL is a really smart move to start building up your own resource of snippets of code. For example, polynomials. Exponential, circular, and elliptical. That sounds like it'd be kind of hard. Probably not terribly difficult to get ellipses or whatever. Would be kind of cool. Could I get percent? It's doing a smooth step. I was thinking of trying to do a way to make a radial design. And you totally could by doing like something with the vector. st.x plus st.y. And I think square root. Yeah, and if you square root this, this is the distance from the center. So if you modulate this with a sign or something, that could potentially be something that curved around a circle and looked neat. Yeah, that was pretty dope. I know what you're talking about. I saw it too. Okay. Digital artists and creative coders have a particular love of working on their own shaping functions. A link to some more functions. transition functions to GLSL. Pay attention to the small changes required, like putting the dot on floating point numbers and using GLSL names for C functions. Coolio. That's neat. No, this is a shader toy. Oh, I guess it doesn't exist anymore or something. And this is just giving some programs. Okay. It's been about 2 hours. I'm gonna do maybe at least this page. We haven't had much of a chance to talk about GLSL vector types. Before going further, it's important to learn about these variables, and the subject of colors is a great way to find out more about them. If you're familiar with object-oriented prototyping paradigms, you've probably noticed that we've been accessing the data inside of vectors like any C-like struct. Defining color using X, Y, and Z notation can be confusing and misleading. That's where the other ways to access this same